Welcome to today's webinar. The topic today is analysis of existing slab with construction measures using construction stage analysis. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the German and English webinars, technical content of the website, customer projects, and so on. I will be the moderator today and I will answer your questions during the webinar. My colleague Ulrich Lex will be the presenter today. He works in our customer support team and he's the main responsible person for the development of the add-ons glass design, masonry design, and construction stage analysis. You can ask questions when you click at the button with the question mark, then enter your question in that field, press send, and I will receive your question. And I will answer you. You can also write us an email after the webinar to info@dlubal.com and you will get an email back with the answer. Okay, that's all from my side for the moment. I hand over to Ulrich. Ulrich, you can start.
Thank you very much, Andreas, for your introduction. Also from my side, hello to today's webinar about construction stages. The topic of today's webinar will be to compute an existing concrete slab where we would change the system, where we would change the loading, and we want to use here the add-on construction stage analyze of RFEM. We want to discuss maybe 4 topics today. At the first, the input and the analyze of the system are prepared here a little bit for you. The second thing is the input of possible reinforcement, the input of additional members, and so on. The third part will be the creation of the different stages, the different construction stages. And as a last part, we want to talk about the calculation and the results of it. That's all for now with the theory. We can switch directly to the program. So as I said, I have prepared some things to make it easier for modeling. As a most important part, what is created is the existing concrete slab. Here we used concrete with a thickness of 25 centimeters. The supports are point supported and in the middle are line supported in the first stage. So it is important, or it is good to know when we create some different stages to begin the modeling and to take a look at the state of the beginning and to the state of the ending. What I want to say is, here I've created already some openings in the surface. Why did I this? It's because we want, in the second state, we want to have here an opening, so I can take off this surface. But at the beginning, I have to create an opening and fill it with a separate surface, and the same here in the front. The same is with the supports. For the supports, it's In the first state, it's point supported with nodal supports, and in the second state there will be here an line support, like a wall or something else. So that means for the beginning we have to model both in one system, and later on we will decide which support is acting in which state. Okay, the second thing are the loading. Sarah created some load cases already. What I forgot is at the beginning I want to take a look at the base data. For today's job, we have activated different add-ons. The most important thing is the construction stage analyze add-on, and additionally I created the concrete design, the steel design, and the stress strain analyze as well. For the additional tabs, I did not change anything, so there are the settings by default. Okay, so then we can continue with the system. There is a loading. The loading is created. Sarah created some load cases. At the first stage, the self-weight. Here it's up to you how much load cases you are create. In my case, the self-weight will be the same in the first stage and in the second stage. So it's enough to have one load case. If the load case between the different stages if the load is different in the different stages, then it would be necessary to have more than one load case, also for the self-weight. I did this for the live load. I have one load case for the old live load, and I have an additional load case for the new live load, for the new stage, and I created an additional load case for additional loads. Okay, what I did additionally is, in my case, I know the existing reinforcement for the slab. So that's why I created, or I wrote this infos directly in the program. So I created here the surface reinforcement, maybe as a basic reinforcement. It's a mesh Q424, maybe in top and bottom side, and additionally some free reinforcement in the other places. We can also show this reinforcement when we check on the part. So this is a thing what we not know for every existing system, but it's not so important. When you know this reinforcement, then it's easier, because then you can do the check between the existing and the needed reinforcement. When you do not know it, then you have to go one step back and have to compare the stresses and decide with the stresses if your reinforcement is okay, is enough or not. Okay. Then we can continue with the loads. As I said, we want to change the system in the stage 2. We then want to open these openings, and we had a different load. When we take a look at the loads, we have 1 times the self weight. There are only loads, only example loads. It's not anything from any code or something else. We have only self weight defined. It's a live load defined with 5 kilonewton per square meters in the old state and the same in the new state. And we have additionally loads here in the front in the new state, at the new state. Okay, then we can continue with defining the different stages. When the add-on is checked on, then we have here in the data navigator the option to create a new construction stage. When I do this, then I get this new tab. Here I can choose which member surface solids are acting in our new construction stage. So I activate now surfaces because we have no members, and I activate nodal supports and line supports. Here I can choose the different surfaces. What should acting in the first stage? And also the nodal supports. And here I can now select this nodal supports because this both should acting in the first stage. And also the line supports. Okay, continue with OK. Then we can check it when we go to the load cases and combinations. Here we get one item, construction stage 1. If you choose this, then you see all the system as you have defined it. Here we see now only the nodal supports because they are acting at the construction stage 1. So for my situation, for my second situation where I want to deactivate the surfaces, I want to create new things, new members as an support. And here I want to add a member on this line and here, and check afterwards if these members are enough as additional supports in stage 2. So then I can start with the modeling. I choose my lines and edit these lines. I add here a member. I choose a cross section, maybe an EPE. Okay. Okay. So now it's in the center line. I can change this when I add some eccentricities. It should be acting on the top and the transverse to a surface. And this should be on the bottom side. Okay, and this on acting on member start and member end. Okay, then it's located on the bottom side of the surface. So one special thing is when I create my members in this way, then each FE node is connected from the member and from the surface. So we would have big normal forces at the system. So when I do not want to have this normal surface, when I want to have that my steel member is sliding between the concrete slab and the steel member, then I can add here a special object. It's called line release, and create here a new line release. I choose my lines where it should acting. I can create here a new line release type. So I only have a small spring constant in x-axis, and the other forces are fully transferred. Okay, and I want to release my new created members. This one, and this one. Okay, and want to say okay. So now it's the case. What the line release is doing, the line release creates here new nodes. So my surface is the surface node is acting node 41, and the member node is acting on 76. Here I can it can be careful, because when I want to know that the support is acting in stage 2 on the member node, then I have create here an additional nodal support, and choose here the new created node from line release. Okay. So this is all for the moment. Then we can continue with creation of the stages. Now I want to create my stage 2. I can create here a new stage. When I do this, then I have the option to create a completely new stage where I do not consider any previous stage. I can change here from start, or I can use here a previous stage. That means that set the deformations and so on. And so from the self weight is transferred from the first stage to the second stage. And also the activated things, surfaces, nodal supports are transferred from stage 1 to stage 2. In stage 2, I can modify it. I can modify the system in this way. Now here should additional the members are acting. I can choose it. 1, 2, 3. Okay. Then my surfaces are active 1 till 4. But here I want to have only surface number 1. That's why I can deactivate the other surface. That means I create this opening in stage 2. Okay. I can take a look on the nodal supports. Here nodal support in stage 1, nodal support 41 is acting. And here I can add this nodal support '76. Okay. And I want to change and I want to deactivate this one and this one. This one and this one. And the 41. Okay. And here I want to add some line supports. I want to add here, because here in stage 2 should acting a line support instead of the nodal supports. And the same here. Okay. So when I continue with OK, I can do the same as before. I can take a look on my stage 1. My stage 1 I already created before. And in stage 2, I have now here my line supports. I have my members, steel members. I have my created openings and the line support here in the front. Okay, so when we did this, then the different stages are finally created. So the next step, what we could do, is to take a look at the loads. Here I can open the load combination and load case dialog. When a construction stage is activated and some stages are created, then we have here a new tab, construction stage. Here it is possible to assign different load cases to the different stages. We want to start with stage 1. In stage 1, there are acting my self-weight and also the live load in load case 2. in stage 2 should be acting the self void, but not the load case 2. It should acting load case 3 and 4 instead of load case 2. And this is all what we have to define. We only have to say in which stage with load case should be acting. Okay. So when we continue, then we can go here to the design situations. Today, for the example, I only have created 2 design situations, one for the ULS and the second for the SLS design. When you want to do all the checks for the different materials, maybe concrete, steel, and so on, you maybe would need more design situations. But today it's more important to show how the construction stage is working, and not so in detail the different checks for the materials. So that's why I have only 2. And now it's possible to assign to this both design situations the different construction stages. Here I can use the combination wizard. When I change or when I modify this wizard, I have the option to consider here an initial state. And here I can choose the stage 1. Okay, when I do this, then we see that the load combinations are created automatically for my design situations, and they are acting in stage 1 only load case 1 and load case 2. The same I can do for a second stage. Here I only create 2 new. Well, I copy these design situations. I can also new stage, and here I can say old stage, and now I can modify my wizard when I copy this again and say, okay, my initial stage should not be the stage 1, it should be stage 2 in this case. Continue with OK. Assign this wizard to design situation 3 and 4. And then we see that there are additional combinations are created. The same what we have before for stage 1 was now acting for stage 2, and we see here are acting only load case 1 and 3 and 4. So this is the way how you can create different combinations for the different stages. Okay, let me think. When we continue here with OK, then my different combinations are created. You also can now check these combinations graphically. It's so when a stage is considered. Then also the objects, the activated objects are displayed. When I switch to maybe combination 2, then I see that my nodal supports are acting. And for the combination 7, the line support and the members are acting. So as the last part, we can check the FE mesh. Maybe it's the length of 0.25. It's okay for this case. And then now we can continue with the calculation. Here I can choose calculate all and try to run my first try. As results, we will see that we get 2 result types. It's on the one side the static analyze results, and on the other part the results for the different add-ons. This you can choose here one time the static analyze results, and on the other side the results of the different add-ons. So when we take a look on the results on the different stages, then I can choose here maybe for deformations. In stage 1, we see that the surfaces in the openings are acting. And when I look at stage 2, then also the members are acting. So our input was okay, I would say. For my case, where I defined my reinforcement before, I can check now directly the results of the concrete calculation. And here I can decide which results I want to see. By default is here checked on the maximum of all of selected design situations. Here I can maybe deselect these design situations, and I want to take a look only at the stage 1, at the old stage. For the old stage, when we take a look on the reinforcement on surfaces, and here maybe the not covered reinforcement, we see that for the old state, the reinforcement is okay. Only the small things, but I think it's okay. Here you could use some surface result adjustments to smooth this small things, but it's okay. It's a singularity. And now we can easy check if the reinforcement is also okay in the new stage. When I do this, then we see that only here in this part it is not okay. That the reinforcement is not high enough. So when we do not know the exact reinforcement and the existing surface, then we have to check the static analyze results. Maybe you can use here the internal forces. You can check here, or you can compare then the different internal forces. It is not possible to overlay some two results, so you have to compare it visually. Maybe this is possible when you create here a new window and say, okay, you want to see it both together. Then you can on the one side activate the results for maybe stage 2, and in the other case the results for stage on the one side the stage 1 and the other side the stage 2. Here you can use also maybe the result sections when you create here, maybe for this node. And result section. Then we see here's the difference, the different values, for the different stages. These pictures or these results you can then easily print to the printout report, and in this way compare the different stages. It's more easy when you know the exact reinforcement. Then you can say, okay, with the not covered reinforcement, you can compare it. So as we see here, it is the reinforcement is not enough. So we have to add some things. Maybe we could add here an additional steel members or something else. I prepared here something new, and we can add here an additional beam as well. Therefore, I created here some lines. So these lines are not exactly in the surface. They are downside of the surface. For these lines, I can choose one line and edit this line and want to add here a new member. This new member is called rebar, and this rebar member can assign to this surface. So for this rebar, I have to activate here a mother surface or a master object, and I have to choose some cross section. So I choose here something like a bounded reinforcement. We have it in our material database. It's called CFK. From different producers. We have it in the database and under fiber reinforcement. From different producers, Sika and Stowe. And this you can use also in our case. Okay, here it is important. I want to add it to all my surfaces, to all my created lines. So here, one member cross section is okay, and my master object is this. Okay. Okay. And the last one is this one. Okay, for this type rebar, it is important that the section of the rebar and the section of the surface is connected. That means when we take a look on the surface and I want to activate some clipping plane. Here is this one. Okay. So I can take a look at my. So it is important that the cross section of the surface and the cross section of my rebar are connected. I cannot assign this master object when here is a gap in between, but I can assign it when this rebar is inside the surface, or at least when it's the boundary is connected together. So what is happening now? When I add this rebar, then we can take off, and here it's filled. Okay, then we can compute again. Here's a concrete design. And we can take a look if there is something changed. So when we take a look on the results, then we see that some members that there is nothing happen because I forgot to activate my members. So I want to do this afterwards. I have to modify my construction stage, and I have to add here my new created members, my rebar members, and I have to add it in stage 2. So 1 to 4, okay. And now I can run the calculation again. So it would be better to check it before. And now we see that my not covered reinforcement is nearly enough, or my reinforcement is nearly enough. What has happened? This rebar members get also normal forces. These normal forces, and therefore I need not so much reinforcement, or my existing reinforcement is enough in my concrete slab. So for this rebars, or for this bounded reinforcement, we do not have a special design add-on. The only possibility, maybe the producers have some tools, or the only possibility is that we can do a stress-strain analyze. You can here add a stress-strain analyze, maybe, and choose here maybe the sigma in X direction to check it to a limit stress, and run here in this way and design. But it's only a stress strain. Maybe you need here some additional checks for it. Okay, the results itself for the construction stage. I want to take a look maybe on, we want to run the steel design. Here you get also the different results when you do a design. You get the results for the different stages. In this case, stage 2. When we take a look on the concrete design, we have also the results for stage 1 and stage 2. These are the same at the printout report. And the most important thing is to document the different results, or the differences between the the different stages to document it graphically to the report. As I showed, you can easily create a second window and compare in this way the different stages. So in this way, this is all from my side. I want to say thank you for listening. Hopefully it was a new information for you. And in this way, I want to say thank you and give back to Andreas.
Thank you, Ulrich, for your presentation. At the end of the webinar, I have an additional hint to our online courses. There's the RFEM 6 course, that's a course for beginners. Then the Eurocode 2 course for the reinforced concrete design with RFEM 6. Then the Eurocode 3 course for the steel design. The Eurocode 5 course for the timber design. The Eurocode 8 course for the earthquake design. And the AI Masterclass course. You can get more information when you click at the links here or scan the QR codes. Now you can get an Eurocode course or the RFEM 6 course for free when you submit your customer project, and we will publish it. You can scan the QR code or click at the link here, then you reach a form where you can upload your files. You can also write me an email to info@dlubal.com and I will write you back which files and which information I need. Okay, then a hint to our free online services. For example, the Dlubal community. You can ask questions there and our support team or other community members will answer you. Then the GeoZone tool for the determination of snow, wind, and earthquake loads. You can determine cross-section properties, download 3D models, for example, as a template for your project. You can download the free trial versions of RFEM 6, Slab 9, Wind 3, and Section. And we are running for 90 days. You can find more information on our website, dlubal.com. For example, the recorded webinars. You can find knowledge base articles. You can ask the AI assistant Mia all the time. Just try it. Okay, that should be also all from my side. I thank you for your attention. Thanks again to Ulrich for your presentation. I wish you all a nice rest of the day. Bye-bye.